This is the third video that I'm putting together for the instruction on how to use Flir tools to perform image analysis and thermal tuning. The first video we registered the software and loaded files into it, loaded thermal image files to it. The second video that was put together walked through an example of finding reflected temperature, and we're going to use that reflected temperature now in finding the emissivity of an object. And so if you've watched the second video, the reflected temperature, what we ended up getting was 78.1 degrees Fahrenheit, and that'll be important when we get into our emissivity example. So let's go ahead and get started. So here are the two files we've been working with. I'm going to open the emissivity example. This is a box that's used for training, thermographic training. And if you look on the right side, you can see there's two pictures. Every time the thermal cameras take an image, they take a thermographic image and they also take a visible image. Now the visible images are fairly low resolution compared to even the cell phone camera that you would have. However, we can see that we have it's a gray box, and from the outside you can't really tell much. But inside there's a light bulb, an incandescent light bulb that heats up. And then there's a piece of electrical tape across the bottom, and this is the 3M electrical tape that has a known emissivity of 0.95, and so we can use that as a reference in order to find out what the emissivity of the rest of this box is. So we're going to go to this image. Now the first thing I do want to point out is you can see that the image itself, there is a temperature gradient. With the light bulb being inside, it's obviously hotter up top and directly in line with the light bulb. And so when we do the emissivity, we want to find a piece of the box that's very similar temperature. Some other things to point out is you can see the box itself is very bright, very warm compared to the background, and for our purposes we don't necessarily need all this background, and I'd like to get a little bit more definition of the box itself, and so to do that I can focus in on a temperature range that's more the box. And so at the bottom there's this slider. I can slide it up, and you can see as I slide it up, certain areas of the image start to turn black almost. I don't want to go too far, I don't want to leave off any of the box, but it gives me a little more temperature gradient in the area of the box, so I can see what areas are similar color or different colors. The other thing that you can see here, the camera in this case was set to 0.95. You can also see the camera reflected temperature was set to 80 degrees on the right side of your screen. And so what we're going to do is put in that last test, we found that the temperature, the reflected temperature in the environment here was 78.1, so I'm going to put that into the reflected temperature here. I'm also going to click the show all box and show some of my other parameters. So distance 0, we just assumed 0, and we were within a foot or two. The distance is going to affect how much the atmospheric temp and the relative humidity have an effect here, and because we were fairly close to the box and the effect of these is fairly small, I'm not going to worry about it. So if we leave the distance at 0, that effectively means the atmospheric temp and the relative humidity, it doesn't matter what those are set to, they're going to cancel out. And then same thing with external optics. External optics transmission 1, we are not using an external optic window, and so 100%, there is no blocking, there's no window that we're shooting of the picture through that's going to block anything, so I set that at 1. And so when that's the case, the external optics temp also is negligible. It's not going to make any difference at all as long as the transmission is set to 1. So really the only two parameters we're worried about are emissivity and reflected temperature. Now we know that the electrical tape has a 0.95. We're not sure what the surface of this box is, but we would need to know in order to accurately measure the temperature anywhere on the box. There's a couple different ways we can look at it. First of all, you can see we can't see in this visible image, we can't see the electrical tape. We know it's somewhere down in this bottom third of the box, but we can't see it. And this is purely a thermographic image. We can change our image modes a little bit up here along the top bar. You can see we've got like a thermal fusion and that we can set what'll show thermal versus what won't. We can use what's called thermal blending, which is one way of overlaying the picture, or another one is this one over here, thermal MSX, which helps us see where the tape is. Now, one thing to be careful of is if there is any misalignment between the visible picture and the thermal image, it could throw this off a little bit. I know for a fact this image and things were in focus and it's in pretty good shape, so we're going to use this. So what we need to do is I'm going to get the average temperature of this piece of tape here, and I'm going to do that. I'm going to take a box measurement tool, and I'm going to cover most of the thermal tape, but I'm going to leave it inside the borders just a little, just in case the visible image that's giving that is not aligned with the thermal image perfectly. I'm not going to go right to the edges. I'm going to give me some error room. But this box comes up, and what I'm going to do with it is I'm going to, first of all, I don't need a max or a min. I'm just going to look at the average. So now you can see this box measurements on the right, box 1, average 104.6. I'm also going to right click on it, select local parameters, and I'm going to use local parameters, and I'm going to make sure that's at 0.95 and 78.1. I'm not going to change that. Now that matches the overall parameters, the emissivity of 0.95 for the image. However, when we start figuring out the emissivity of this box, I'm going to be changing this emissivity level over here on the right side, but I don't want the emissivity in box 1 in my tape reference box to change. So that's why I've set this to use local parameters and set an emissivity of 0.95. That's going to lock it in for this box right here. Now what I can do is create a couple other boxes, and I want to put them in an area that's pretty similar temperature. So I'm actually going to create a few of them. I'll put one here, and I'm going to put another one over here, and I'm going to put a third one kind of just below it. And now I know above it starts to get warm, so I'm not going to put one above it. But with each of those boxes, I'm going to get rid of the minimum and maximum, just do average. Box 3 right here, minimum, maximum, get rid of it. Box 4, get rid of the max, the min, keep average. And then these boxes, however, I'm not going to set local parameters. So you see, I'm going to see leave local parameter. I'm not going to select that. Now it's getting this emissivity, the reflected temp, and the distance are going to come from the image parameters that are over here on the right side of the screen. And so now what I can look at is I compare boxes 2, 3, and 4 to box 1. You can see they're all similar to each other, which is what we want. So I'm measuring a similar temperature, and I'm on left, right, and below, right next to my tape. So it's probably pretty accurate, but you can see they're reading 103, 103.2, 103.4. And we compare that to our box 1, which is 104.6. So really, they should be closer to that 104.6. And so the way we're going to do that is we're going to start to change the image emissivity, the overall, which will change it for these 3 boxes. You can see there's a little eye here next to box 1, which is our tape box. It's at 104.6. That little eye right there means we're using local parameters, and I can see what those are set at even as I change the image parameters. So now I'm just going to try a few things. So I'm going to try 0.9 and watch what happens to box 2, box 3, and box 4 when I hit enter. You can see now their temperature has actually gone up a little bit, and that's because we're saying that it doesn't. We're telling the image software that the paint material, the gray surface material of this box, doesn't give off quite as much heat as it should. It reflects a little bit more heat, and so we have to tell it the emissivity is lower. It emits a little bit less heat, but it doesn't mean it's necessarily cooler. So you can see now they're at 104.3, 104.5, 104.8. So you can see they're just above, just below. And so our emissivity is probably close to 0.9. I'll try a few others. 0.92, still a little bit low. 0.91. You can see this is kind of a guess and check method. 0.90. Let's try 0.89. Oops, 0.89. 104.6, 104.8, 105, and that might be a little bit high. So I think 0.90 is our ideal, and again we leave that 78.1. So you can see now the image parameters, the emissivity is 0.90. You can see our boxes here match up with box 1, which is our tape box. Our tape box is still, if I hover over the eye here, the info, it's still set at 0.95. So the emissivity of box 1 right here is 0.95 on the tape. The emissivity of the rest of this test box, I should say, not measurement box, but the actual object, it has an emissivity of approximately 0.90. And so that's what we would want to have now if we're going to check temperatures anywhere else. So now, for instance, if I wanted to find out what the hottest point was, and this is a little bit of extra, I could cover a box on the whole thing. I could say I just want to know the max and min temperatures with markers, and now we can see this red point right here, 100 is 108.8, and our cool point is probably falling, yep, because I have the edge of the box off the side. Let me bring it on at least. There we go. Our coolest point is up here on the lid on the right at 97.3 degrees Fahrenheit. And so that's how you can see now we are getting anywhere in this box or any temperature we take, as long as the emissivity is set at 0.9 on the surface here, we're going to get an accurate temperature, taking into account, remember we put the reflected temperature we found earlier and the emissivity of this specific object, this gray paint surface.